So we've spent a day talking about how to solve a system of equations that you set up from a word problem. So we did word problems for our first day. Now for day 2, we're just going to spend some time practicing. So at the top it says, remember that you could use a T diagram, which I think is referring to what we did back in the equation chapter with the find know chart. So if that helps you, you can still do find and know to help you figure out your let statements and the information you should be using. And you can also use the flow chart that we used yesterday or in the previous lesson when we did word problems for the first day. So if you look at the very back of your notes, after these 4 problems, there are extra copies of the flow chart. So if you need to go ahead and go back there to do the problem, you can do that. So the way this video works is that you're going to try one practice problem on your own and then resume the video to check your answers. And you'll continue on like that for all 4, there's 4 of them. Yep, all 4 word problems. So try it and pause the video and then resume the video to check your answers. Okay, so at this time, you should start working on the problems and then resume the video when you're ready to check number 1. Okay, so number 1 says Gregory's Motorsports has motorcycles, which are 2 wheels, and ATVs, which are 4 wheels in stock. The store has a total of 45 vehicles that together have 130 wheels. How many motorcycles and ATVs does the store have? So remember, our let statement is coming for what we're trying to find. So we're going to let X equal the number of motorcycles. And then we will let Y equal the number of ATVs. Okay, because those are the 2 things we're trying to find. How many motorcycles and how many ATVs. Okay, so then we're going to go into the problem and start using the facts that we know. It says the store has a total of 45 vehicles. So that means between motorcycles and ATVs, we should have a total of 45. So that should be X plus Y equals 45. Our next fact is that they together have 130 wheels. So this is an example of one equation being the total number of items and the other equation bringing in the value. So if we start with motorcycles, we know that a motorcycle has 2 wheels. So we need to have 2X plus Y for ATVs, they have 4 wheels. So that'd be plus 4Y. And that's going to add up to 130 wheels. So based on the way this is set up, it looks like elimination is our best option because they're both in standard form. Our variables line up. And as is, we do not have any opposites. So we need to create opposites. So I'm going to go ahead and get rid of the x's. And if this is 2x, I'd like for this to be negative 2x. So I have to multiply this equation by a negative 2. Now, you do not have to do it the same way that I did. Wait and watch the video to see if you end up with the same result. You might have just chosen to get rid of a different variable or multiply by a different number. So this creates a new equation, negative 2x minus 2y equals negative 90. And then I still have my 2x plus 4y equals 130 that I did not change. So now when I add these together, the x's are gone. Negative 2y and 4y makes 2y. Negative 90 plus 130 makes 40. I would divide by 2. And y equals 20. So I know for right now that there's 20 ATVs. It wants to know how many of each we have. So I do have to go back and find out how many motorcycles now. So pick whichever one you'd like. I'm going to pick the top one. X plus y equals 45. But I already know y is 20. So I'm going to subtract 20 from both sides and see that x equals 25. So now I'm going to double check it. Going back to my word problem. So it says a total of 45 vehicles. So I'm going to do 20 and 25. That is 45, so we're good there. And then I'm supposed to have 130 wheels. So I have 25 motorcycles. So motorcycles only have 2 wheels. That would be 50. I have 20 ATVs. They have 4 wheels. So that's 80. And if I take 50 and 80 and add them together, I get 130, which is what I was supposed to have. So now I know for sure there are X was 25, so 25 motorcycles. And 20 ATVs. Okay, so again, pause the video, try number 2, and when you're ready to check your answer, resume the video. Okay, so now in number 2, you've got Katya baked 36 cookies. There are 8 more chocolate chip cookies than peanut butter. How many cookies are there of each type? So we need a let statement for each type. So let X equal. Now remember, you have to be specific. Don't just put chocolate chip. I don't know if that means how much they cost, how many you're making. So you have to be specific. This is the number of chocolate chip. And we'll let Y be the number of peanut butter. And both are cookies. So that's where we're starting. Now the first fact that we have is there's 36 cookies. That's how many Katya baked. So that means my chocolate chip plus my peanut butter should be a total or equal to 36. The next one we have is that there's 8 more chocolate chip cookies than peanut butter. So my chocolate chip cookies are equal to the peanut butter ones plus 8. Now that's how I'm looking at it. You could have Y equals X plus 8 or negative X plus 8, sorry. Maybe you have X minus 8 equals Y. Okay, there's variations there. But the way I'm looking at it is my chocolate chip are my peanut butter plus 8 because there's 8 more chocolate chip than peanut butter. Okay, now the way that this is set up, I would think substitution is best because we have one equation that's either in X equals or Y equals form. So if X equals Y plus 8, I'm going to take Y plus 8 and put it in the other equation in X's spot. So this top equation is no longer X plus Y equals 36. It's X plus, sorry. This equation is no longer X plus Y equals 36. It's Y plus 8 plus Y equals 36. So that means I have Y plus 8 plus Y is 36. The Y's I can combine to make 2Y plus 8 equals 36. So I subtract 8 from both sides. 2Y equals 28. And then I would divide by 2 to see that Y is 14. So I know I have 14 peanut butter cookies. I now have to go back and find how many chocolate chip I have. So I'm going to use the X equals Y plus 8. But I already know that Y is 14. So now I can see that 14 and 8 makes 22. So I just want to make sure I double check using the quick way of checking. 36 should be the total. So if I have 14 and 22, that's 6, 36, that works. And it says there's 8 more chocolate chip than peanut butter. So I want to make sure my chocolate chip number is more. 22 is more than 14. And then I want to make sure the difference between them is actually 8. So if I do 22 and I subtract 14, I do get 8. So that works. So now I know there are 22 chocolate chip cookies and 14 peanut butter cookies. Okay, at this point, pause the video and try number 3. Resume the video to check your answers. Okay, in number 3, the yellow cab company charges just 0.25 or 25 cents a mile, but it costs $5 to get in the cab. Express Cab charges no fee to get in the cab, but $1.50 a mile for the ride. For what length of drive is the cost equal? So what you have here is 2 equations that are actually set up in an mx plus b format. You have a rate and a y-intercept, or starting value, for each one. So it says for what length of a drive is the cost equal? So there's 2 things here. Length of the drive, so how long you're driving, miles, and the cost. So we're going to let X equal the number of miles. And then Y would be the total cost. So for Yellow Cab Company, it's 25 cents a mile and $5 to get in. So the total cost is equal to the 25 cents per mile, which is X, so 0.25X, plus the $5 it's going to cost just to get in the cab. Okay, just to get in the cab. Express Cab is giving you a total cost, so Y equals, of this time it's $1.50 per mile, so 1.50X, and it has no fee to get in the cab, so I have nothing to add to it. So these are my two equations. So this to me would be substitution. I'm going to take what Y is equal to, and it doesn't matter if I pick this one to put over here, or if I pick this one to put up here. If Y equals both of these things, they're equal to each other. So if Y equals 0.25X plus 5, I'm going to put it in the other equation in Y's spot. So I end up with, do it down here, 0.25X plus 5 equals 1.50X. So I had no distributive, no like terms. I do have variables on both sides and it's uneven in size. So I definitely want to get rid of the 0.25X. So I end up with 5 equals 1.25X. And I would be dividing both sides by 1.25. So 4 is X. So it looks like my number of miles is X. And I need to know what the cost would be at that time. So if I wanted to know that, I would do Y equals 1.50X. I can pick either one. And I know X is already 4. So I see that that ends up being 6. So now I can do some checking. I want to make sure I know what everything is adding up to. So they're both supposed to be the same cost. So I'm going to check this one. 0.25 times X is supposed to be 4. So 25 cents for 4, that's $1. And then we're going to add 5 to that because I had to pay $5 just to get in the cab. So that's a total of $6. So that one's okay. So now we got to check Y equals 150X. So I want 1.50. Well, I'm not checking the equations. I'm going up here. 150 a mile. This was 25 cents a mile. I did that. Plus 5. I did that. So now I'm looking at $1.50 for a mile. And we know we went 4 miles, or what we think. So I'm going to multiply that, and I end up getting 6. So I'm getting the same price for each one. So I must have found the correct number of miles. So they will cost the same at 4 miles for a total of $6. Okay, this is your last one. You're going to pause it, try number 4, and then resume the video to answer the question. Okay, in number 4, a friend bought 2 boxes of pencils and 8 notebooks for school, and it cost him $11. He went back to the store the same day to buy school supplies for his younger brother. He spent $11.25 on 3 boxes of pencils and 5 notebooks. How much would 7 notebooks cost? So this one's a little trickier, a couple little things in here. I know it says how much would 7 notebooks cost, but really we need to know how much 1 notebook costs. And he was also buying pencils. So we want to write a let statement for both because we're going to need both to set up the equations. It's just that we'll think about what we're going to write for our answer at the end. So let X equal the number of boxes of pencils. Again, don't just put pencils because I don't know if it's price or number unless you specify. And then I'll let Y equal the number of notebooks. Oh, how much would they be? That's my fault. Let's back that up. It's price. Price of boxes of pencils and price of notebooks. I apologize. Okay, so now we're going to write our equation. So first one, 2 boxes of pencils, so 2X, and 8 notebooks, so that'd be plus 8Y, should be a total of $11. And then when he went back, he's got a total of $11.25. So I'm going to put that on the total side for 3 boxes of pencils. So 3x plus 5 notebooks, 5y. So we're going to use elimination. And we don't have opposites, so we have to create them. And we're going to have to multiply more than one of our equations by something to do that. So common multiple between 3 and 2 would be 6. It's going to be smaller than these, so I'm going to choose to get rid of my x's. I want these to be 6 and -6. So I'm going to multiply the top one by -3. That'll give me the -6 I want, which means I need to multiply this by a +2, so I have the +6 that I want. So I'm going to distribute here. And I get -6x minus 24y equals -33. And then I'm going to distribute a 2 through this one. And I get 6x plus 10y equals 2250. So then when I add these together, my x's are gone. And I have -14y equals -1050. And then I would divide both sides by -14. And y equals 0.75. So I know that's the price of the notebooks, which is what they asked me for. So I actually do not need to go back and find x in this case, because they're only asking me for notebooks, which means I only need to find y. Now, if you do go back and find x, or you found x, you would have to go back and find y. So now I know y is 75 cents. So that means the notebooks are 75 cents a piece, but they wanted me to say how many it would be for 7. So I'm going to do 7 times 0.075, which ends up being 525. So now I know 7 notebooks. Oh, you can't see that. Sorry. 7 notebooks costs $5.25. So that concludes word problems day 2.